Okay, pre-calc fans, today we're looking at the last set of notes from our locus writing equations based on locus definitions. Okay, so remember last time we were in class, we did the first few definitions. We did 3 definitions for locus. We did d units from a point. We did equally distant between 2 points, and then we did equally distant between a point and a line. Okay, so today what we're doing is d units from a line, equally distant from 2 parallel lines, and then we're going to do equally distant from intersecting lines. All right, let's start off with the first one. And remember, we needed our distance formulas. Remember, we had 2 distance formulas. We had the point-point formula. So we had our d equals square root of x1 minus x2 squared plus y1 minus y2 squared. So this is our point-point. And then we had our big giant absolute value one, and that's our point line. So our ax1 plus by1 plus c over a squared plus b squared. This was your point line formula, point line distance, pt for point. Okay, so first question, well, d units from a line. So what formula here are we going to be talking about for doing d units from a line? Right, d units from a line. So in general form, write the equation for the locus of points that are 6 units from the line. Okay? So mentally, if you're thinking about it, here's a line. Here's our line. Our x plus 3y minus 2 equals 0. We have to be 6 units from the line. So if you remember your scenario, here's 6 units, and here is 6 units. So we're going to be creating parallel lines. So I'm going to show you how we do that. Okay. First of all, the line has to be in general form because we have to use this formula. That's right, we're using this formula right here. So we're going to be using the d equals the absolute value, formula 1. So x1 plus a x sub 1 plus b y sub 1 plus c all over a squared plus b squared. Sorry I'm writing small. I think I'm just going to need more room. Okay, so let's get things set up. So 6 units. So where does the 6 go? That's right, it goes in for the d. And what's the equation of the line? Right here. Okay, remember, we don't fill in the x and the y. That is your arbitrary point, x comma y. Okay, on either side, we'll get it taken care of. I'll show you how magically it appears. We get our 2 equations. So absolute value of this, x plus 3y minus 2. Okay, I don't worry about the equal 0. Okay, because that's the formula. It's just ax1 plus by1 plus c. We literally fill in x1 and y1 with x and y. With x and y. Okay? That's literally what it is. This x and y right here is representing this x and y in this equation. Okay? All right, and then over your square root of 1 plus 1 squared plus 3 squared. All right, everything else is algebra and cleaning it up. So I have 6 equals the square root of all over square root of 10. Absolute value of x plus 3y minus 2 all over 10. Now how do I solve something like this? That's right, we have to cross multiply. So I have absolute value of x plus 3y minus 2 equals 6 radical 10. Now, we have an absolute value problem here. Okay? How many answers are we supposed to get with an absolute value? That's right, we're supposed to have two. One part positive, one part negative. Okay? So, this is what I'm going to do. I'm going to write it out just like we used to do our absolute value problems. One part positive, so I'm going to drop the absolute values. And then I'm going to just, then over here, I'm going to have negative the parentheses equals 6 radical 10. Okay? I want to do the easy side first. That's this one. The x plus 3y minus 2 equals this. Remember, I want general form. So I have two equations. I just have to pop into general form. So literally what I just have to do is just take the 6 radical 10 and kick it to the left. So x plus 3y minus 2 minus 6 radical 10 equals 0. Done. That's general form. What's your a? Good. A is 1. What's the b? Good. B is 3. The c is this entire quantity, negative 2 minus 6 radical 10. In other words, if I wanted a decimal answer here, we could type this all into a calculator and just give me some random decimal answer. But this is your A, B's, and C's. Okay, folks, I'm just showing you where the A's, the B's, and the C is coming from. So this whole thing right here would represent the C. You don't have to do this. This is all I'm looking for. Okay, here. My algebra says to distribute the negative. So negative x minus 3y plus 2 equals 6 radical 10. So now, I think what I'm going to do, I'm going to take all of this negative stuff and put it on the right-hand side. So I have my x's. I want my x to be positive. I just like my x's positive. So this is what it's literally going to look like. X plus 3y minus 2 plus 6 radical 10 equals 0. There. We're done. Okay, we're done. Notice my two equations. What's the only thing that's different? Right, it's just the plus 6 radical 10 and the minus 6 radical 10. So hopefully the next time you see this with the radical, you can just say, oh, I add the 6 radical 10 and I subtract the 6 radical 10. Okay, that's literally what we did here. Okay, it's literally what's going on here. Hopefully you'll start to recognize that. It'll make your work a lot faster. Okay, it'll make your work a lot faster. All right, next one. What's different about this equation? That's right, it's not in general form. Put it in general form. And you know what? Me personally, I don't want to deal with fractions, so I'm going to multiply everything by 4 as I'm putting it into general form. Okay? So what am I going to do first to put this in general form? Let's see. I think I'm going to subtract the y first. Oh, heck, I'll just multiply everything by 4 first. So I have a 4y equals 3x minus 12. I multiplied everything by 4. Now I'm going to make this equal to 0. So 0 equals 3x minus 4y minus 12. All right. Here's your line in general form. Here's your point. Here's the, we have to be 4 units from this line. Okay. Oh, before we do anything else, remember these lines right here are parallel? Look at my two equations here. What do you notice about the A's and the B's? That's right, 1 and a 3. These lines are parallel. Your X's and Y's are your A's and B's are exactly the same. Your lines are parallel. The slopes are the same, right? Slope is negative A over B, so negative a third. Slope here, 1, 3, negative 1 over 3. Your slopes are the same. Your A's and B's are the same. The A's and B's are the same. The lines are parallel. So we know we did it right. All right, down here. So we're going to be 4 units from the line. So when we start filling in the line, remember, our x1 and our y1 are literally filled in with a random point called xy. So that's why we can just write 3x minus 4y minus 12 over 3 squared plus a negative 4 in parentheses squared. Oh, Mr. Prada was nice. How'd I get 5? That's right. 3 squared plus negative 4 squared is 25. Square root of 25 is 5. Wow, was I nice. So 5 times 4 is 20. Okay, now here's your 2 absolute values. All right, here's your absolute value here. We have to do our 1 positive, 1 negative. So I'll put the positive over here. And then I'll put the negative here. You guys do whatever algebra tricks you got to do. Okay, I could just divide everything by a negative. So get rid of the negative here and put the negative here. So I'm going to add 20. Then here I'll just subtract the 20. There we go. Yes, I think you guys can see that when I'm dealing with this, I could have just made the right-hand side here a plus 20 and a minus 20. So 1 positive 20, 1 negative 20, then we could have done our magic. Are these lines parallel? Yes. What do you notice about the A's and the B's? They're exactly the same. All right. Equally distant from parallel lines. Equally distant from parallel lines. Yes, these lines are parallel. We want to be equally distant from parallel lines. So here's my parallel lines. Where's equally distant? Right, dead center. The line that's in the middle of them. So this is what literally happens. So since we're talking parallel lines here, we're literally talking, there's 2 ways of doing it, the long way and the short way. I'm going to show you the long way because the long way is the method that we're going to use when we have intersecting lines. Then I'll show you the shortcut way. Okay, so the long way. Okay, we have our point line formula equal to point line formula. That's the long way of doing it. But this is the method that you have to use when we do intersecting lines. All right, so let me start filling this in. So I have 2x minus 3y plus 1 over 2 squared plus negative 3 squared. And then this is 2x minus 3y minus 8, and then it's over 2 squared plus a negative 3 squared. So I'm going to do a little cleaning. I'll write larger. This is 13 at the bottom here. 4 plus 9 is 13. All right, now notice. Radical 13 in the denominator here, radical 13 in the denominator here. Guess what? They're the same. That's right, I can cancel them out. So we're looking at this. All right, now, how do I solve this? Excuse me. How do I solve this? Well, in order for us to solve this, we have to have, it's a double absolute value problem. Remember how I did it with 3 listings, 3 groups? Well, I don't need to do that here, okay? It's going to be easier for us to think about it in terms of what do we know about the signs and what do we know about these equations and what's our answer going to look like. Well, what do I mean by that? Well, remember, we would have categories of a plus plus, right? Both pieces are positive, or we could have both pieces are negative. Okay? So this is positive, this is positive. This is negative, this is negative. Okay? Then we had the groups of one's a plus, one's a minus. So this is the plus, this is the minus. Or else we had the grouping negative plus. This is the minus, this is the plus. Okay, that's technically your grouping for absolute values. Okay, because this is a positive or a negative, this is a positive or negative. Now let's look at these. We have grouping here that are the same. Plus plus and minus minus are the same. They'll give us the exact same results because of the absolute values. Okay, so I only need to look at plus plus. What about these two? Yeah, these two are exactly equal to each other as well. They're identical. So I only need to look at one of them. So I'm going to just scribble out this. So whenever you have, when we're doing these locus questions, and we are dealing with absolute value equal to absolute value, all we have to worry about is plus plus, or else we worry about plus minus category. Okay? And it does not matter which one we make plus and a minus. It does not matter, trust me. All right, so let's start with the plus plus. Let's see what happens with the plus plus grouping. So I have my 2x minus 3y plus 1 equals 2x minus 3y minus 8. Well, what happens here? That's right. 2x gone. Minus 3 is gone. I'm left with this expression, 1 equals negative 8. Does this mean anything for us? No. This side does not exist. So plus plus doesn't even exist for us. So this is empty. So that means our answer has to come from plus minus. So I think what I'm going to do is I'll make the left side plus. So I'm going to do my plus minus category now. Now the algebra says to distribute. All right, let me sit back here. So we did plus plus, everything cancels out, left with an empty set. Doesn't exist. So plus plus doesn't exist. And now plus minus, I made this one plus, this one the negative, I distributed. Now I just have to make it say equal to 0 and we're done. So I'll add, I'll subtract, and then I'll subtract. So I'll add 2x to this, I have 4x. Subtracting the 3, I have a minus 6y. And then I'm going to subtract the 8, and I have a minus 7 equals 0. So there is our equation of the line. That is parallel to these two. What's the slope up here? Right. Our slope up here is negative 2 over a negative 3, so 2/3. So the slope up here is 2/3. What's the slope right here? Right, 4 over 6. But what do we know about 4 over 6? That's right, it's negative 2/3. So the lines are parallel. Okay, and this is in between them. All right, I don't have enough room to show you the shortcut on this paper, so I'm going to do it on another sheet of paper. The shortcut to this problem would have been literally to analyze your question a little bit more closely. Now, what happens? We know these lines are parallel, right? Let me ask you this question. What happens when I just start look at this, everything's the same. The x's are the same, the y's are the same. How do I find the middle here? So can't I just add these two equations together? So I just added those two equations together. Isn't that our answer right there? Yeah, I'm done. Okay? But if I wanted this equation right here to look exactly like this, 2 and the 3, I can then divide by 2. And if I divide by 2, we have 2x minus 3y minus 3.5. So look at your 1, look at the negative 8. Where is the middle of a 1 and a negative 8? Remember, middle, midpoint. Add them, 1 plus a negative 8 divided by 2. That gives you a negative 3.5. That's your shortcut. But that only works if the lines are parallel. It does not work if the lines are intersecting. Okay? All right, I'm going to turn the paper over. I'll let you digest that for a second. All righty. Look at my question 4. Yep, my lines have to be in general form. This is not in general form, so I have to rewrite this. So I'm going to write 3x minus y plus 1 equals 0. Mr. Parada, you did not put these in your a's. I cannot just add these up because these x's and y's are not the same. You can manipulate it to do your little trick. We could manipulate this, okay? We could multiply this by 2 and then add it, and we'd have our equation. You could do that, or else we can just do exactly what we did on the other side, okay? Because these lines are parallel. How do I know these lines are parallel? Well, the slope here was 3, and the slope here is 3. That's right, this slope is 3. If you did not know that, figure it out. Negative a over b. Negative 6 over negative 2, which is 3. Y equals mx plus b. Slope is 3. These lines are parallel. Okay? So if you did not know that these lines are parallel, you would have to do exactly what we did on the other side. Okay? If you're sure that these lines are parallel, then you got your little algebraic manipulations that you could do. You could multiply this all by 2, and we would have our 6x minus 2y plus 2 equals 0. And now these two are exactly the same except for the c's. And all we got to do is find the middle of the c's. Okay? So we can just do 6x minus 2y minus 5 equals 0. 6x minus 2y plus 2 equals 0. Add those up. There's your equation. Okay? There's your equation. We're done. All right, last question. Equally distant from two intersecting lines. So, guys, by the way, I use the shortcut here. Okay? I did this all by the shortcut. When you do question 5, okay, all I'm going to do is one of these. When you do question 5, when you see questions like 5, there is no shortcut. You have to do what we just did. Okay? All right, so these are intersecting lines. There is no shortcut for this. You have to set up your equations just like we did. So 5x minus 12y minus 4 over the square root of 5 squared plus negative 12 squared equals negative 6x plus 8y plus 1 over square root of negative 6 squared plus 8 squared. Yes, I was nice on your homework. I was nice. I want these in general form. So 5 squared is 25 plus 144 is 169. So this gives me 13. So this is square root of 169. And then here we have 36 plus 64 is 100, so that's 10. And now I have to solve. I'm going to cross multiply, and then we'll worry about our absolute value stuff. So cross multiply, so I have 50x minus 120y minus 40 equals 13 times 6. I don't know what 13 times 6 is off the top of my head. So 13 times 6, 78. So I got a negative 78. 13 times 8. Oh, we use big numbers. 104. Plus 13. Okay. Just like we talked about on the other side, we have to do the plus plus, and we have to do a plus minus. And then once you have them set equal to 0, your work is done. You have to do your 2 categories, because that will give you your 2 equations. So plus plus, I just drop absolute values. And I just so I'm going to add, oh my goodness, 128x. I will subtract, so negative 224y, and I will subtract negative 53 equals 0. My first equation is done. So I think to save some time, no, never mind, I'll just write it all out. So negative the parentheses. I gotta squeeze this all in. Distribute my negative. That's a 13. So I'm gonna, let's see. I'm gonna add, subtract 50 from here. So this is 28x. I'll add the 120. So that's at plus 16y, and then I'll add the 40. So that's minus, plus 53. Alrighty, here we go, all done. These 2 equations are perpendicular. If you're not sure, what's the slope here? Here's your little slope test. 128 over 224. What's the slope here? Negative 28 over 16. If you multiply those together, they will equal negative 1. I'll prove it. 128, got a bunch of stuff there. 128 times a negative 28 is negative 3584, and 224 times 16 is a 3584. Look at that. We have negative 1. Remember, if you multiply them together, you equal negative 1. You know your slopes and lines are perpendicular. So that's a little test for yourself to make sure that you're not crazy. Okay, you guys can do that one on your own. You'll see them in your homework assignments. Have a good day.